Hi, everybody. I know you don't have these blank notes, but if you jot down some of these formulas, then you'll have them to use as reference for the quiz next week or on your homework rather than having to refer to the video. I will also post a formula sheet, but sometimes if you just have it written down somewhere, it's a little bit faster and easier to work with. So what we're going to do today is we're going to connect polar and imaginary or complex. So as you know, polar is r theta, and then complex numbers are a plus bi. So we're going to put these two things together, which seems like they really don't go together at all, but they actually do. So again, we've got some of the same things, they just over and over and over again. We've called the length from, let's say, the hypotenuse, right? We've called that magnitude. We've also called it absolute value. Today we're going to call it R. So it's all the same thing. It has the same formula. It just has lots of different words. So R is, as you know from Pythagorean theorem, the square root of a squared plus b squared. No tricks there. And so just nice and easy. Now, in order to deal with the angle, so that's going to take care of our angle, we also want to deal with the smallest positive angle formed by the real axis and the vector. So again, as we would rotate from z, so for example, you don't want to call an angle, let's say for example, we had a 15-degree angle, nice and easy angle. You would not want to call that 375 degrees, let's say, because that's not the smallest possible angle. So we want to go with the smallest number. So we're going to try to relate r and theta, but we also want to use a. So if we look at a is the adjacent side when dealing with theta, and r is the opposite. So we have opposite and adjacent, and so this is going to be that the cosine of theta is equal to adjacent over hypotenuse. Then if you cross multiply and solve for a, you get a equals r cosine theta. This is exactly how we will find that part of the imaginary number. Relating this to b, as you can see over here, b is the opposite side. I don't know why I put an O there. Sorry, this is the hypotenuse. And so we're going to have that the sine of theta is equal to b over r. And again, if we cross multiply this, we get b equals r sine theta. Then we're going to get real tricky, and we're going to just put an I there just to make it imaginary. So those are the three formulas. I'm going to show you how to use them here in number 4. It says write the polar form of z. Z is a number. We want to put it in r and theta. And so we know that if we put this together, z is equal to r cosine theta plus I sine theta. This is basically a plus bi. Oops, I forgot my r. Now, if we factor out an r, because they both have it, the easier way to write z is r cosine theta plus I sine theta. So since they both have r, it seems silly to write r over and over again. So we'll just write the r once, but we do have to write the angle twice. So it's the same angle, but we do have to write it twice. So that's what our answer is going to look like. Let's put that together here with some numbers. So we're going to write this in polar form. First thing we want to do is we want to find r. So r is the square root of a squared, don't make this difficult, plus b squared. No I, nothing tricky. So r is radical 58. Leave it like that. Do not make it a decimal. For the angle, again, we've done this. It's inverse tangent of b over a, or the tangent of theta is equal to b over a, dropping the I, negative 3 over 7. Of course, we've got to remember what quadrant this is in. 7 minus 3i is down here in the fourth quadrant. So you got to take your answer and add 360 to it. So we get 336.81 degrees. Put it in the fourth quadrant. That's probably the hardest part about it, is not using, just trusting the calculator. So then we just put all this together. This is how easy it is to write a polar number that's a complex number as well. You put the r out here, radical 58, and it looks crazy, but it's as simply as writing cosine of 336.81 degrees plus I sine 336.81 degrees. That's it. Like I said, it looks absolutely ridiculous, but that's what it is. All right, so this is one of the things I forgot to do the other day. You may run into this, so I especially want to go through. You may even see it from Alex. So I thought maybe you need a better explanation than what Alex can give you. So we're going to find the distance between two complex numbers. And the definition is that their distance is the difference. So we want to do some subtracting. It's not crazy, but it might not be that intuitive. So we want to make sure we go in the correct order. So we want to do z minus w, because that's what it's asking for. So 4 plus 2i minus negative 3 minus 5i. And so then we want to go ahead and figure this out. I'm going to distribute that negative sign. And we get 7 plus 7i. Then we want to do the absolute value of their differences. So you subtract it first. And absolute value, as you know, is just the square root of a squared plus b squared. No negatives, no i's, nothing. Now you can probably do this without writing it out too much, but we would call this name the absolute value of z minus w. And we would do the square root of 7 squared plus 7 squared. Now, as you know, this is like a Pythagorean theorem problem. When your legs match, the answer is 7 radical 2 for the hypotenuse, or 5 radical 2. It's just the leg radical 2. So this is going to be 7 radical 2 without going through too much arithmetic. Now, this last little bit, again, looks kind of crazy, but it's really, really pretty easy. So you can see at the top there, it says, how do we multiply these complex numbers in polar form? And there's a long formula there. I tried to simplify this, or I did simplify this a little bit, and just by explaining it to you in words rather than having to read all that. So you're going to multiply the radii together, but you're going to add the angles. That's all you do. So basically we have two numbers here. We have two complex numbers that are written in polar form. So if you are multiplying, you multiply the numbers together, the whole numbers together, so we would get 15. Now you can't change the sine or the cosine, you leave that alone, so then we would have cosine, but add the angles, 30 plus 45, so the cosine is 75, plus I sine of 75. And that's it. That's all there is to it. That's how you multiply those two numbers together. Now, let's go back the other way. To take your complex number and put it into rectangular form. So rectangular form means no sine and no cosine and no theta. So rectangular means we travel left and right and up and down. We do not travel in circles. So it looks like distributive property. It is a distributive property. Be prepared for some unit circle. Try to warn you about that. It goes away for a really long time, and then it comes back. So we're going to have 7 cosine of 150 plus 7i. Don't worry about the I, it just sticks around. Sine of 150. The cosine of 150, yikes, it's over here. Cosine's negative there, so it's going to be 7 times negative radical 3 over 2. And then this one is going to be 7i, and the sine is positive there, 1/2. And so we get negative 7 radical 3 over 2 plus 7i over 2. You're more than welcome to leave it like that. Sometimes in Alex, they're really picky about the answer, so you may have to write it as a common denominator. Let's try one that has an angle that lands right on an axis. Again, distribute 3 cosine of 180 plus 3I sine of 180. Well, the cosine of 180 is -1, so this is 3 times -1. Remember, you get rid of the angle, you get rid of the word. And then the sine is 0, so we have 3I times 0. If you recall, 180 is over here. This is the point -1, 0. Unit circle is in alphabetical order, cosine sine, x, y. And so when we go to multiply this out, we just get plain old -3. And that's it. So you don't have to have radicals or fractions or any of that stuff. Sometimes it's nothing. Now for number 10, we're going to put this together with what we did the other day in the video. Maybe you didn't watch the video, and that's a shame. So we're going to write the polar form of the conjugate of this number. What we learned about conjugates of complex numbers the other day when we graphed it is that it reflects, helps if you can have a marker here, reflects over the x-axis. That's what we know about conjugate. And also don't forget that if the name of the vector is like this, then its conjugate, the conjugate name has a little bar over it. It's a lowercase letter, no little arrowhead or half arrowhead on it. That's the symbol for conjugate. So if we think about reflecting this over the x-axis, so right now we're at 48 degrees. That's how you draw 48 degrees in standard position. And we want to reflect it over the x-axis. So we want to be 48 degrees down. That is essentially -48, but we don't want to write it as a negative angle. So you have to do 360 minus 48. This is 312 degrees. That part matters. So the conjugate, this doesn't have a name, so I'm just going to use the word conjugate. The conjugate is simple. The radius length isn't going to change. It's the angle that changed. So then it's the cosine of 312 plus I sine of 312. And that's it. So these look really ridiculous, but they're pretty simple. In terms of multiplying them, you multiply the radii, add the angles. When you're putting it back into rectangular form, distribute, use the unit circle. When you are going from the first way, which was to go from a plus bi to r and theta, then you have to use those formulas, which you will be given. Don't forget to do your homework, and all you have to do is check the answers. They will be posted.